Today I'm going to be talking about altitude sickness resistance in bar-headed geese. For one thing, the bar-headed goose, here's a picture right here, is one of the world's highest altitude flying birds. They fly at extreme altitudes towards the summer nesting grounds from lowlands in India to the Tibetan Plateau. And the highest altitude they've seen is over Mount Everest, which is about 29,000 feet. And the migration is generally made in one continuous trip and can be done as little as 7 hours. Right here is just the general altitudes of birds. Most birds are in this range, 1,000 to 2,000 feet above sea level. These are various highland species right here, about 4,000 above sea level meters. And then here's the bar-headed goose, all the way at the top. So it is one of the highest flying bird species ever. Now the thing is, how is this sustained flight at high altitudes? How do they do it when there's oxygen that is scarce, the temperature is low, and the air density is low, so that has to be difficult for them to generate lift. This has to do with a couple of things. For their morphology, they have hemoglobins that have higher affinity towards O2. They generally have a larger heart. The left ventricle has more capillaries than any other species. This allows for more efficient oxygen to be distributed throughout the body and the blood, because the left ventricle is what pushes out the oxygenated blood. The mitochondria are closer to the sarcolemma. This means that there's less distance that the oxygen has to diffuse from the capillaries to the mitochondria, and they have larger lungs. And generally what accompanies these larger lungs is an increased surface areas for more gas exchange to occur. And the larger wing surface area than other birds of the same weight, this allows them to generate more lift to stay afloat at those high altitudes. Now, for this graph right here, it shows the saturation of the hemoglobin with O2 compared to other species. You can see here how the bar-headed goose has the highest, and this is the Canadian goose and the Peking duck, but the bar-headed goose has the highest. For the physiology that comes into play with this is what many avian species have is the cross-current gas exchange with a unidirectional flow. So the air comes in through the trachea, and then here's the air sac, and here are the parabronchi where the location of gas exchange occurs. As you can see, there's a lot of space and surface area for that gas exchange to occur, and then it goes into the parabronchi. This is the collar air sac to the cranial air sac, and then it gets pushed out through the trachea. In addition to that, there are several blood vessels that are insensitive to hypocapnia. What this is when the carbon dioxide concentration in the blood gets too low. This generally happens because of hyperventilation or hypoxia, and they are resistant to the alkalosis of the blood. And when that happens in blood, it constricts. There's a vasoconstriction of the several blood vessels, which will cause dizziness, and they can pass out. And if they fall from that height, of course, death. There's an increased amount of ventilation in conjunction with hypoxia, so when there's not enough oxygen coming within, the amount of air that they bring in increases proportionately up to a certain point. But that is one of the things they do, so they keep on having stable levels of oxygen in those oxygen-scarce environments. Now, here's some of the differences between the bar-headed geese with the lowland species is about their lungs are generally about 25% larger. There's 30-40% higher capillary density, and 50% of the mitochondria are located near the sarcolemma compared to about 35% for the lowland species. Mitochondrial respiration is regulated by the creatine, and that's it. That's the references.
Okay, that was some good numbers. Is that the references where you got all that data from?
Yeah.
Okay.
Yeah.
And what an appropriate name, bar-headed?
Goose.
Because goose, and there's the bar on their
On the head. Yep.